Okay, before we leave chapter 8, I want to finish where we first started about the importance of diversification. Let me show you, recall that we started here. We basically said that as we increase the number of assets in our portfolio, we reduce the amount of idiosyncratic or firm-specific risk, and all we're left with is systematic risk. This is super important when discussing the single factor model. Only systematic risk matters, and when we can properly identify that systematic risk, then when we estimate a single factor model, the alpha is going to give us the risk adjusted expected return. Well, let me pick up where we first started. We have the returns for a particular portfolio is equal to alpha for the portfolio plus the exposure that the portfolio has to the systematic risk event plus the error. Okay. Again, this is me estimating this, and that alpha is going to be the expected return on the portfolio after accounting for the exposure to that portfolio to the systematic risk event, whatever. Okay. So here we have the returns of the portfolio. Let's say that the returns of the portfolio is just going to be equal to the sum of the different weights of each asset I to the returns of asset I. So the returns of the portfolio are just equal. This is the left-hand side variable. This is just showing you that the returns of the portfolio is just the average, the weighted average of the returns of each individual asset in the portfolio. And on the right-hand side of this equation, we have the weights of each alpha plus the weights of each beta, right? Plus the weights of each individual error term. Okay. So all I'm doing is I'm trying to identify what the returns of the portfolio might look like, but I want to look at this as individual assets. Now, let's make the naive assumption that the portfolio is just equally weighted. All right. So all we're doing is we have 10 assets in our portfolio. So here n equals 10, and each asset is weighted 10%. Okay. Asset 1, we have a weight of 10%. Asset 2, a weight of 10%, and so on. Okay. So watch what I'm going to do. This is, if they're equally weighted, I'm just going to add up all of the returns of all 10 assets in the portfolio, and I'm going to divide by n, which is 10 here. And then I'm going to do the same thing on the right-hand side of the portfolio. Okay, and I'm left with the alpha for the portfolio is just equal to the average alpha, equally weighted average alpha of each asset in that portfolio. The beta of the portfolio is just equal to the average, the equally weighted average of the beta. Okay. And then, of course, that's multiplied by the systematic risk event. And then the error term here, which is my idiosyncratic risk, is just equal to the average, okay, the equally weighted average of the error terms. The portfolio variance is therefore sigma squared subscript p. This is the portfolio. The variance is equal to the exposure of the portfolio squared times the sigma, or the variance of the systematic risk event, plus, and this here is going to be our idiosyncratic risk, the variance of the error term of the portfolio. Okay. Again, systematic risk cannot be diversified away. However, idiosyncratic risk can. So let's focus down here on this equation here. If we assume naively that the portfolio is equally weighted, look at what we do here. Okay, we have the weight. Okay, we actually look. We can just show this here, right? Here's what we have. And so sigma squared, the variance of this error term becomes, I'm just going to square the weight here, okay, times the variance of each individual epsilon. Okay, if I pull 1 over n, one of the 1 over n's outside of the summation and include 1 over n inside, I can get the average. So this is the variance of epsilon I. The line above that just means that's the average of the epsilon I, and I still divide that by n, okay, because I had to square my weight here. All right. So notice it can be shown that if I take the idiosyncratic risk and I take the limit as n, the number of assets goes to infinity, what's going to happen? What is the limit? What is the limit of this here as n goes to infinity? As n gets larger, all right, as n gets larger, this thing's going to get smaller. And as n goes to infinity, in the limit, this thing is going to equal 0. This is proof that the idiosyncratic risk of a well-diversified portfolio can be diversified away. This has important implications. The only risk that matters is the systematic risk. Okay? And alpha, once we know that we can diversify away all of the idiosyncratic risk, that means that the only thing that matters, because we can't control, hey, listen, we can't control the systematic risk event. We can't control the pandemic as an investor. The only thing that matters is the alpha. And we call that the risk-adjusted expected return. This is going to be super important going forward. This is what I want you to understand and know going forward. We're going to talk a lot about theory and stuff like that, but the application of this is in number 3. Sure, we can prove the idiosyncratic risk can be diversified away. Sure, we can understand that the only thing that matters is systematic risk. But that alpha matters, right? We're gonna work on trying to find alpha in various portfolios. We're going to conduct a whole bunch of back tests. We're going to learn how to back test. In fact, the project in this module is learning how to back test these buy and hold trading strategies in order to find alpha.